This video will show you how to use mathematical induction to prove that summation of 4r over 3 power r minus 1 for r equal to 1 to n is equal to 9 minus 2n plus 3 over 3 power n minus 1 for n belong to the set of positive integer. Understanding the notation for this symbol. Now, what is actually on the left hand side? What does it mean? The left hand side is actually a sum. Summing up what terms? The term is sum up is 4r over 3 power r minus 1. What is r? R from 1 to n. So when you do this, start with r equal to 1. 4 times 1 over 3 power 1 minus 1. Then r equal to 2. You get 4 times 2 over 3 power 2 minus 1. Then r equal to 3. You get 4 times 3 power 3 minus 1. Then r equal to 4. You get 4 times 4 over 3 power 4 minus 1 until the last number r equal to n. You get 4 times n over 3 power n minus 1. This is what it means on the left hand side. Understand this, then you understand how I prove this. I'm going to let p of n is equal to summing up 4r over 3 power r minus 1, r from 1 to n, equal to 9 minus 2n plus 3 over 3 power n minus 1 for n belong to positive integer. And we know the left hand side is actually a sum. 4 over 3 power 0, 4 times 2 over 3 power 1, 4 times 3 over 3 power 2, 4 times 4 over 3 power 3, 4 times 5 over 3 power 4, and so on until 4 times n over 3 power n minus 1 is on the left hand side, and the right hand side is just 9 minus 2n plus 3 over 3 power n minus 1. To use mathematical induction, you have to show that P1 is true. How? Knowing that Pn is this term on the left hand side, let's look at the left hand side of P1. By putting n equal to 1, the left hand side of P1 is 4 times 1 over 3 power 1 minus 1. That is 4 over 3 power 0 is 4. By putting n equal to 1 to the left hand side, I have actually 4 over 3 power 0, which is actually the first term. The right hand side of P1 is putting n equal to 1, you get 9 minus 2 times 1 plus 3 over 3 power 1 minus 1. You get 9 minus 5, also 4. So, the left hand side of P1 and the right hand side of P1 are equal to 4. So, P1 is true. Step 2. Assume Pk is true for all k belong to the set of positive integer. That means that sum of 4r over 3 power r minus 1, r from 1 to k, is equal to 9 minus 2k plus 3 over 3 power k minus 1. How do we get this? We get this by changing n to k in Pn. Pn is what? Pn is this statement. This is our Pn. Changing n to k. And we will get this Pk. Now, then we're going to prove that Pk plus 1 is true. So you must know what is Pk plus 1. You use Pn and change the n to k plus 1. So when you change the n to k plus 1, this is what you get. How do we prove that? You start from the left hand side. Left hand side of Pk plus 1 will be this term, 4r over 3 power r minus 1, where r from 1 to k plus 1. Now this sum can be split up into sum from r equal to 1 to k, and then the last term is when r equal to k plus 1, which is 4 times k plus 1, or 3 power k plus 1 minus 1, by substituting r equal to k plus 1. Now we use an assumption, the sum of the first k term by using pk, saying that the sum of the first k term is this. So make use of here. So the sum of the first k term is 9 minus 2k plus 3 over 3 power k minus 1, plus the term just carry over 4 times k plus 1 over 3 power k plus 1 minus 1. Now how do we sum them up? How do we continue? First, notice the denominator are different, so you must have a common denominator. We can multiply the term here by 3 on the numerator and denominator. So I get this. Why want to do that? Then the numerator will be 3 times 2k plus 3, we get 6k plus 9. And denominator is 3 times 3 power k minus 1, which is actually 3 power k plus 1 minus 1, since after you multiply, increase the power by 1. Now, the second term and the third term has a common denominator. So you can combine them to become 9 minus 6k plus 9 minus 4k plus 4, because the last term 4 times k plus 1 is 4k plus 4. So we can combine them into this way. Notice the sign, this is negative because in front there's a minus sign. Negative and negative, we get positive, which is the last term. And then 6k minus 4k, you get 2k, and 9 minus 4, you get 5. And notice that 2k plus 5 is equal to 2 times k plus 1 plus 3. And that is exactly the right hand side of pk plus 1. So pk plus 1 is true whenever pk is true. Since we know p1 is true, by mathematical induction, Pn is true for all n belong to set of positive integer. That is the end of the proof.